Hi, so this video is a continuation on solving exponential inequalities. So we did 1 and 2, I believe, in the previous video, so let's do question 3. So we have to solve 5 to the power x squared greater than 2 to the power x, and we want to give our answer in terms of logarithms. So well, if this is bigger than this, then if I take log base 10 of both sides, and again, if I don't write the base, it's implied that it's 10, then the inequality does not change, right? So log base 2 of x. Because the log function is an increasing function. If this is bigger than the log of this, the right-hand side. If right-hand side is bigger than left-hand side, if the left-hand side is bigger than the right-hand side, then the log of the left-hand side has to be bigger than the log of the right-hand side. And now we can use our rules to do some simplification. Log 2. And now we can say that, hey, we can subtract x log 2 from both sides. And the reason why I'm doing this is because if we divide by x, then we don't know whether x is positive or negative. So we are not sure about if the inequality sign has to flip or not. So this is another way to look at this problem. I can factor out an x. X log 5 minus log 2 greater than 0. And now there are two possibilities. So if I want the product of two numbers to be positive because it's greater than 0, then either both numbers are positive or both numbers are negative. So let's say x bigger than 0. If x is bigger than 0, x log 5 minus log 2 must be bigger than 0. X log 5 must be bigger than log 2, and x must be bigger than log 2 over log 5. And remember, because 5 is greater than 1, then log 5 is positive. So x is bigger than 0, x is bigger than this. So basically, there are some numbers between 0 and log 2 over log 5. But we don't need, those numbers will not be satisfying our inequality. So we want to take this one. That is our solution. So this inequality holds if x is bigger than log 2 over log 5. Because if x is greater than 0, if x has to be greater than 0, and if x also has to be greater than this, then, well, it's all the numbers that are greater than log 2 over log 5. So there are some numbers between 0 and log 2 over log 5 that do not satisfy this inequality. Because we want all of our numbers to be positive and to be greater than log 2 over log 5. So we only choose this part. And the second thing is that we can have x less than 0. And we can have x log 5 minus log 2 less than 0. So if both of them are negative, then the inequality should also hold. And basically get x less than log 2 over log 5. So there are some numbers between 0. So I want my x to be negative, and I also want my x to be less than log 2 over log 5. Well, all negative numbers are less than log 2 over log 5. But there are some numbers between log 2 over log 5 and 0 that are not negative. So we don't want those numbers. So we will only consider x less than 0. So our solution is x less than 0 or x greater than log 2 over log 5. And hopefully that explanation made sense. So you have two answers. It's either x is less than 0 or x is greater than log 2 over log 5. So the question 4 is a proof question. So we have to prove that this inequality, 2x minus 1 times 2 to the power 1 minus 3x greater than equal to 5, has that solution. So let's just take the logarithm of base 10 of both sides. We have 3 2x minus 1 times 2 1 minus 3x. And this is bigger than or equal to log 5. And the base is 10, that is implied. So we have log 3 to the power 2x minus 1 plus log 2 to the power 1 minus 3x. So we use the multiplication rule for logarithms, log 5. And we can see 2x minus 1 log base 3 plus 1 minus 3x log base 2 is greater than or equal to log 5. And now we can just isolate our variable x. So we have 2x log base 3 minus log base 3 plus log base 2 minus 3x log base 2 greater than or equal to log base 5. Now if I add log 3 on both sides, this is going to cancel out. Or you can just send this to the other side. You have log base 3. And that is the wrong way to say, sending things to the other side, but it works. Basically, what we are doing is we are adding log base 3 on both sides. And in this side, we get log 5 plus log 3, and these cancel out. And now we can also subtract log 2 from both sides. And this is simplifiable. Log 5 plus log 3 is log 15 by 2. So this side simplifies to log 15 by 2. And this is what we have here. So we're getting closer to the answer. So we have 2x log 3 minus 3x log 2 greater than or equal to log 15 over 2. And now we can factor out our x. And let's think about it. We have log, because we have a 2 here, this is actually log 9. And this is actually log 8, right? 2 to the power 3 is going to give us log 8. So we can write this as log 9 over 8. And 9 over 8 is bigger than 1, so this is positive. So overall, our answer is x is great. So we can divide by log 9 over 8 on both sides. So our answer is log 15 over 2 divided by log 9 over 8. And that is exactly what the question has asked us to prove. So you can rewatch that explanation and think it over on why this is how you can prove it. So question 5, we are not allowed to use a calculator. You are given that log this is equal to this, correct to 5 decimal places, and that, okay, we are given 2 facts. So find the number of digits in the number 4 to the power 100. Let's try to think about this question. Well, if I have, say, log base 10 to the power 4 is equal to 0.60206, then I can multiply by 100 on both sides. And the reason why I am multiplying by 100 might make sense in a while. But I get here on the right hand side, I get 60.206. And now this is log base 10, 4 to the power 100, and 60.206. Now I can take, because if these expressions are equivalent, then I can just exponentiate 10 to these numbers. So 100 should equal to 10 to the power 60.206. And now this simplifies to 4 to the power 100, right? Because 10 and 10, so you get 4 to the power 100, equal to 10 to the power 60 times 10 to the power 206. Because 0.206, right? 10 to the power 60 times 10 to the power 206, right? Now, this is less than 2. So 4 to the power 100 is equal to 10 to the power 60 times 10 to the power 0.206. And I know that if 10 to the power 0.206 is less than 2, then 10 to the power, so I can actually multiply 10 to the power 60 with 2. Why? Because if this part is less than 2, then if I multiply a positive 10 to the power 60 on both sides, then it doesn't matter. It's still going to be, the inequality does not change. So we have 4 to the power 100 is less than 2 times 10 to the power 60. So how many digits in the number 4 to the power 100? So let's think about it. So I think that to get the number of digits, we can use this as a clue. Well, let's think about it. So 10 to the power 0 is equal to 1, right? And 10 to the power 0.206 is less than 2. So that means that has to be between 1 and 2. So that is what we know. we know that this is between 1 and 2. So it's going to be 1 point something, right? And it's 1 point something, and we're taking the decimal points 60 decimal places away. So you have 1 point something, 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 something here, and then we're moving this 60 points away. So you're going to have 61 digits, I believe. So you're gonna have, I think, 61 digits, and the first digit is going to be 1. And the reason that it is 1 is something that we just discussed. So yes, because we're moving the decimal places 60 times, and we have 1 point something, then when you move it 60 times, then you get 61 digits before you have your decimal point. And because you're starting, we just discussed that it has to be 1. So I think that is the answer for 5.